So hello everyone. Welcome to today's water cooler chat where we talk about all things Livepeer, whether it's orchestrating, delegating, broadcasting, transcoding, or AI inference. We're here to ask questions and get answers. So we have a couple topics ahead of us. A little bit about the subnet testing, AI, some CUDA and Linux, Dancun, and some other items like Livepeer Studio and things like that. So I'm going to start off with some of the big ones. Mostly, let's just start off with the AI work that's coming along. So I would like to start off with, I guess, the broad announcement, I guess. There was, I believe it's public now, Rick, is that correct? That we're going to start with a subnet testing using the actual payment system of the orchestrators on Arbitrum starting this week or next week. Is that correct?
Yeah, that's correct. So I contacted several of you or some of you to participate in the first test. It's now a pre-alpha test to say, just to test if the ticket system is working and to see if our failover is working and to see how fast it works. So get some performance metrics. I think Rich also updated. Give me one moment. It's in the AI video chat. Yeah, so he did not yet update you about the next phase, so we will update you about it later. So after this, we will, let me check. Yes, I got the message. So after this, we will do another update with a sign-up form for other orchestrators to join the next phase. That's the alpha phase, where we will test the subnet with more orchestrators.
Great. Well, I think this is a good place to start, actually, is around the setup. Authority, you mentioned your question. Do you want to reiterate your question real quick? I think that's a good place to start of, like, what can orchestrators expect for running this AI runner? Rick, or yeah, Authority, you want to clarify your question?
Yeah, I'm just curious what goes into it, if it's similar to stuff we're all used to, if there's some new things. I did hear there's like a lot of flags to tweak and mess around with. But yeah, just curious what that looks like from a high level.
So I just finished like the setup guide for the small pre-alpha. That setup guide is very similar to the original transcoding pipeline. So we have two kinds of setup. We have the binary setup. That one, you can use the binaries that will be in the bulk channel for the AI video brand. Basically, then you just download the binary, unzip it, and run the Livepeer command on the binary. The other setup is the Docker installation. That one is just by pulling a Docker container and then running several commands on top of that Docker container. So the only difference with transcoding there is that you have to set up like an IE model JSON to specify which models you want to support and which models you want to have warm, so already loaded on the GPU. Apart from that, the flags you're talking about, from the setup side, there are not many flags, but there are some flags, for example, used for memory optimizations and speed optimizations. But we still yet have to decide if we want to include them already in the binary or have them set up already, because we still need to do some benchmarkings on that.
Okay, you mentioned loading certain models. Do you think there will be like some stock standard models that all orchestrators will use, or is it going to be a lot of variance between everyone trying different things?
So at the start, we will support a limited set of stock models. So currently, I think Stability SDLX Turbo, Lightning, Stable Video Diffusion 1.1. The other one I don't know out top of my head. But after that, of course, we also are looking to expand our models, and the end goal would be to just have users for the broadcaster or gateway, we call it now, to supply their own custom containers, but that is in the future. So at the start, I think with the launch of the D app, the first one done by Quan and CJ, they are using two models currently, and those will be probably the models that will be first deployed by all the orchestrators. If there is another DGAP deployed after that, it will be more like a free market. That's the starting point. And after that, we have to look at optimizations we can do there. For example, give orchestrators insights and broadcast in what models are used mostly on the network, so you can make good decisions about that. But that's the starting point. Just a limited set of the models just to get some data, metrics, see if our system works.
Okay, and last question, is there a downside to having multiple models warm on the GPU? Is there a performance impact to that, or can one orchestrator just like load up all the models and just be ready for work?
Currently, we still have to do some optimizations on memory. For example, I'm running an off-chain orchestrator now to do some testing, some load testing. I loaded the SDXL Lightning model on my GPU. I have a 390, and I'm about full currently. So it's with if the broadcaster request a size, big size, so 1080, I think, then my GPU would need about 20 gigabytes of RAM. So there are a lot of optimizations that can be done there for stable diffusion models, but we still have to look at that. So currently what we do, we load one model on one GPU, but we will tackle that in the future. So you can load multiple models there. I have not looked if there is any performance downside. If I think about it, probably it will be like the bandwidth of your GPU that's limiting with transferring if you try to do multiple models. But apart from that, I have to look into that in the future.
Cool, thank you. Super exciting.
Yeah, exciting. And did it answer your questions?
Yeah, 100%. Really appreciate it.
Amazing. Great.
My guess is that we're probably going to end up one model per GPU that's warm loaded into the GPU, and the model you choose is going to be the model that fits, because the larger models will earn more because they can do more. So like if you have a 3090 that can fit the image to video model, like you'll probably want to load that one in because it'll earn the most. And then like if you only have a 12 gig card, then you can really only fit like a text to image, maybe some image to image models in it. So I suspect and text to image is just easier to do. So like it won't charge as much is what I'm guessing. So I think the model is going to be relative to the size of the GPU that can handle it. And then that will be kind of the determining factor. At least in the beginning is how I see it.
I think you're correct there. So, for example, if you have an 800, not a lot of people have them, I think nobody here, then of course we can support multiple models, because I think you have around 100 gigabytes, 96 or something. But for consumer GPUs, it will be kind of hard in the beginning if we don't optimize further for like VRAM usage. So at the start, if we have not fixed that yet, then one GPU will be able to load one model.
But even then, like if you had an H100 with 96 gigabytes on it, you would, I can pretty much, I could guess that you're better off loading 4 containers of just image to video, because they're gonna pay the best, right? So like you're probably just gonna do more video, more of the top end work than you are loading up different sets of like text to image, which can be done by lower grade GPUs, which are much more plentiful, right? That's just my guess.
That's a good question, though, as it relates to, if everyone's got the image to video models, but no one's doing the text to image or the image to image, how is the broadcaster going to function? Like, doesn't it need enough resources in each of the categories? Like, it can't have all in one model, right? Like, you're going to have a variety of support across all the orchestrators, no?
I think that's where economics come in. You could just say, hey, you're clearly lacking in your text to image, availability. So, you know, I'll charge more than image to video, and I'll just do some text to image, right? And so, you know, maybe economics could do that, right?
Well, you would need the visibility inside the broadcaster to determine that that's lacking, so that you could make adjustments.
Yeah. Based on my benchmarking, though, I will say that like text to image inference, so a text to image inference, one inference job takes roughly 300 to 500 milliseconds. Okay. The same image to go to video takes a minute and a half on a 3090. So, you know, but you know, I just think that there's going to be a like image to video is just going to be so much more consuming than text to image to begin with, right? So if you could imagine like a crappy 8 gigabyte GPU, not crappy, but just an 8 gigabyte GPU, it can do the text to image part less than a second, and then it takes a bigger GPU to be able to turn that into a video in, you know, a minute and a half. So I think it'll be just a lot easier to do the first portion. So, you know, for every one text to image container, there needs to be roughly 90 image to video to make up to have the same inference speed. So, just to keep that, like, that's just some information.
I think you're right in that, but I think you can also, if there are not enough low GPUs, then you can do multiple or more jobs of text to video. So that will, or text to image, sorry. So that will also, I think, help with the economics. So I think the economics will work it out here.
Yeah.
But yeah, we have to see.
Yeah. It'll be very hard to determine like what people need ahead of time. Just like transcoding is really hard. So
but if you have a 4090, you're probably not going to be doing and loading the text to image and the image to image models, right? You're probably most qualified to do the video, text to video. So you're probably going to be using that higher end hardware for those tasks. Whereas maybe you put another GPU in that's a 3090 or even a 1080 to run some of the lower end jobs, right?
Exactly. Like in the machine that I'm going to put onto the subnet, I got a 3090 and a 4060. And so like the 3090 can handle the image to video. But the 8 gigabyte, you know, 4060, it can only really do the text to image. But then that is the entire pipeline, right? You go from text to image and then image to video. And you know, I might throw that online as both. So now I've got the whole pipeline on one machine, right? That you could do, you know, it'll be called upon separately, but it's kind of there.
Does anyone know? I mean, do the orchestrators have the ability to just load a model and stick with that, or is it dynamic? Can they be dynamically loaded as needed?
They can.
Because
That can be the both. Oh yeah, got one. Sorry.
No, I was going to say, it looks like in Yonden's update from last week, that, you know, it says part of the selection algorithm is checking to see if, you know, if supported model is warm, and then I would assume if it's not, then there's got to be a way to load the model.
Yeah, you're correct. So basically what we do now is at the start of your orchestrator, we look for the warm configuration value. If you set it to warm, we will load that model. So if your GPU, currently we only do one model per GPU, but in the future, if your GPU have one GPU available there that has enough VRAM, we load that model on the GPU. Then the next time, if you have set the other models, for example, the XDL Turbo, and you have the XDL Lightning on warm, and the other one you don't have on warm. So somebody requests a gateway, requests the Turbo model, we will see if there is a GPU available. Currently, we use one GPU, but otherwise we look if there is very one available. And we will load the model on the GPU. So that's dynamic. And if it's not in use and you get another job currently, so this pipeline has to be optimized further. But currently what we do is, if you will then request a video, somebody requests a stable video diffusion model, we will unload the model that's not kept warm and load that model on top of it. So you can see that this can be optimized a lot, but this is the current setup.
Got it. Yeah. Okay.
Oh, so the binary does attempt to unload a model and load models based on demand.
Yeah, correct. So basically what the binary does, it borrows the GPU, and if it's no longer needed and there is no warm flag, it will give it back.
Okay. Can we permanently mount a model into a GPU and not have it dynamic?
Yeah, that's the warm flag.
Right. Okay. So the binary won't try and swap it out even if a broadcaster asks for it.
Yeah, so it will not give the GPU VRAM back if there's a warm model on it.
What would be the benefit of making sure the warm flag is on?
If you're
So
oh, I was gonna, sorry, you go ahead, Rick.
you can go ahead.
No, just from what I was saying, from the selection, it's going to choose a GPU that already has it warm, if there is one that has it warm. So, if you know there's a lot of work coming in and you have a warm model, you're better off probably keeping it warm than letting it dynamically choose.
Yeah, that's 100%
Loading a
correct.
model is expensive and slow, so that's why you don't want it to be loading and unloading models all the time, especially if you're loading and unloading the same model. So you might as well keep it warm if you're doing all that work. Whereas, loading and unloading may make your response times poor.
Okay, thank you.
So, Rick, for my example, I got two GPUs in one machine. I want to warm load, the text to image in one GPU and the image to video in the other GPU, and I don't want them to unload that at all. I want them just to stay static. Is that going to be possible in this subnet testing?
Yeah, so I shared the configuration in the chat. So if you set both models to warm and you have enough GPUs, because currently we don't look at the VRAM, we just look at the number of GPUs. This will change in the future if you have a big enough GPU. Then what it will do, it will load one of the models on one of your GPUs and the other model on the other GPU. So I have to look if we already, I think we don't have the ability currently to set which GPU you want to load it on, because I can see that if you have the 490, you want to load like the video model, so I have to look that up. But that's what it currently does. So your two GPUs will have a warm model and there will be no GPU available for the other models you have set.
Okay. Yeah, I can see how this could definitely, this is the beginning of a very long path of optimization.
Yeah.
Because people
we're already talking about a lot of optimization, but first we want to have this initial subnet, of course, launched so we can see how it performs.
Yeah, definitely. Okay, great. Yeah, that's there's a lot to work through here.
I have a question on the hardware side, if we're still sticking with AI.
Yeah, we're going to be on this for a bit because my next topic is around inference speed. So, yeah, shoot your question.
I'm just curious generally, like how far should we be pushing a rig if we're building something specifically for AI before it gets irresponsible, right? Like there are so many options. I was looking at the AMD EPYC CPUs, and those go up to like $4,000 for one CPU. Is there a reason to go that far and spend that much money? Because I will, and I'll be the stupid guy who does it. So I'm just curious if there's a limit or specific things we should be looking for when picking out hardware.
But did you say CPU or GPU?
Yeah, like what CPU to pair with the GPUs to make sure that there's no bottleneck, and same with memory and all that stuff.
But I don't think the CPU matters. Like just like transcoding, right?
I saw Rick
actually-
mention that it can.
Yeah, because I mean, like the server grade and CPUs will have more PCI lane support. So if you want to have a large machine with multiple GPUs and have them all running at full speed, PCI speed, then you're gonna, that would justify having a more expensive like server grade CPU.
Oh, you're
But the
talking
CPU
about
itself. The processing on the CPU is not going to be like the what you're looking for. It's the support for more PCIe band lanes.
right. You're talking about like building a rig where you're like shoving multiple multiple GPUs into one machine.
Yes.
Yeah, correct.
would-
So in my case, I would want like two 4090s in there, and I don't want to like handicap myself by putting an incorrect part somewhere else.
Right. Yeah. I don't know the answer
Okay.
to that.
Yeah, so it's quite a complicated question, because the reason I cannot speak from this from like the Livepeer side, but I can speak from this as an orchestrator. So basically what I'm doing, I will be a little bit more careful here. So I will buy around three 390s and I will put it in one machine, and I will use a server GPU, but like the Epic, but I will use like a lower level one. For example, that has 3 gigabytes or 3 megahertz, sorry. It's a little bit late. Clock speed, just to have the PCA lanes. But then again, it doesn't matter for all models. So basically, what it does, it can do the writing speed will be faster if you have PCA 5 fully. But PCA 4 on like X8 can also be enough for some models if you just have to load it one time on the GPU, do all the quick calculations there, and write it back. So it only becomes really important if you have like a model that does this writing and reading a lot of times. So that will be different models. Or for example, if you want to use the optimization flag that Titan is exploring. So I think it's the CPU. I forgot how it's called. Like
The
CPU off.
sequential CPU offloading.
Yeah, correct. Thanks a lot.
Yeah.
So if you do that, of course, it will have to write parts of the models out of the GPU to the CPU, store them there, do other calculations, write them back. So then you need this speed. But I have not done benchmarks on it. It's just something that I'm taking into account when I buy this Epic GPUs there, because I want to have enough PCE lanes to not have this bottleneck. But I will not go for the higher end models that cost thousands of dollars. So I will be around the 500 as a price range for the CPU, I think.
Yeah, I'm taking a different approach. I'm just buying a cheap Chinese motherboard CPU all-in-one with one PCI lane in it for like $120. And you just shove that as a, it's more of an auxiliary to the GPU than it is the actual GPU is an auxiliary to the CPU, right?
Yeah, I think that will be other approach, and I think we will see which one works. I think I probably will buy too much hardware here.
They both will work. I just think it'll be how much are you going to spend, like, and how much do you expect to do? Like, if you're going to run all three models, text to image, image to video, and all the different stuff, you're going to need multiple GPUs, multiple PCI lanes. You're going to have to pay for that premium. But if you're just running one model and swapping them around, and maybe if you're lucky, you can squeeze two onto a GPU on a single lane, then then you're going to just do less. But there'll still be, that's a trade-off each person's going to have to make individually.
Yeah, I agree. So my thinking about this is that you can probably do like a PCA 4 on like an X8 or X4. It will be enough for the diffusion models we have now. So you don't need the full PCI lanes. But I have not done testing, so I cannot say that certainly. But the bandwidth they have on the PCA 5, for example, is extreme compared to the model size.
Yeah, I got a PCI 1 riser too. I want to try and put my like 3090 on the riser and see what happens to the performance.
Yeah, please do. That will be really interesting because I have no idea. I just look like at the technical specs and I do some calculation, but I have not done any benchmarking.
Does memory speed not matter as much for AI and Livepeer in general? I'm just looking at the like server grade stuff. The motherboards generally have lower speed, I'm noticing.
I can kind of like, you mean like for performance on like,
Yeah, I'm just min-maxing here, hardcore.
yeah, like
the GPU memory is the primary factor when you're talking about workloads and models. But you know, you don't want to have like a 1 gig, you know, a 1 gig. I mean, the speed's going to be negligible because you're not going to be, you know, swapping a lot of server memory in this process, but it will be used. So any milliseconds you can shave off isn't bad.
But I will say, on the benchmarking I've done, there seems to be no correlation between memory speed or clock speed and results. The only correlate, like I've been really, actually have a new spreadsheet tab called Compare Speeds, where I've written out memory clock, base clock, boost clock, and then the results in the stable diffusion image to video. And I've been trying hard to find out what correlation there is between memories, like speeds and inference time. And the only thing I can come up with so far is the architecture, the architecture year, like the what do we call it? Like the generation. The generation makes the biggest difference. So like the difference between the 3090 and the 4090 are pretty big inference time. But there doesn't seem, the only thing I can figure out is that there's a generational difference between the Ampere and Lovelace architecture. And then same again with the A100 and the H100. Like there's a the H100 is twice as fast, but it has roughly the same gigabyte, same memory clock, same boost clock, same everything, except the architecture is different, the generational. So I'm still working on that to figure out what actually affects performance. Yeah. So, yeah, we could dive into a bunch of optimization and inference testing if you guys want, but Authority, does that kind of answer your question? As of right now, Authority, I would just be really careful of like optimizing your motherboard, because there doesn't seem to be a difference between CPUs or motherboards for inference time. Just like with transcoding, like it's all in the GPU, is what I've seen so far.
Yeah, I think I agree with that. So basically, if you go really low, for example, with a really cheap GPU, you have problems. And the same with if you go really low with RAM, for example, you have problems. But if you have decent CPUs and decent RAM, you will be, yeah, it will be enough. It's the same with transcoding. I think Marco did a benchmark on what was needed. I think I can find it for transcoding. It's like you don't need the X8 PCA4, but you only need the 2 at maximum, I think he said. I can find it. So it will be similar for like, it's a different job, but of course there will be a limit, a lower limit where it will cause problems, but that you have to buy really cheap stuff then.
Yeah, I wouldn't spend very much money on optimizing your CPU and motherboard, because it's mostly in your GPU.
Okay, so don't buy a $4,000 EPYC CPU. I'll just remove that from my cart. 1 sec.
It looked beautiful, the one you sent me. I want it, but it's so much money.
It's crazy, yeah.
Yeah.
So I go with the EPYC just before the PCA lanes, because I maybe want to I want to add 4 GPUs in there. That's the reason why I'm choosing EPYC, not because of the other specs.
But Marco did say like you'll get short compile times, and you'll get the pipelines loaded into your GPU faster, right? But
Correct.
but once it's
That's
warm,
correct.
then like it's not like who cares?
So if you can buy really expensive system with PCIe 5, have all the GPUs on that, yeah, then you will have really fast loading.
Well, the real question will be is how much is a ticket going to pay out for one of these jobs? If it's a $4 ticket like we're getting on transcoding, then you might want to think real hard about that $4,000 CPU.
Yeah.
Yeah, like here, I'll just give you an example of this one right here. So this is the motherboard that I have running for my transcoders, and like I'm also gonna benchmark this motherboard with a 3090. So this motherboard is a motherboard, CPU, and RAM all in one for like $100. And if you could slap like a 3090 on it and you get the same inference time, then I wouldn't buy a $4,000 CPU.
I'm a big fan of that neon green fan on
Dude.
the.
It's amazing.
Yeah,
I got 2 of these things set up. And yeah.
Nice find.
So it's been on for over a year, and it's been transcoding, so it hasn't failed. Now whether it will, who knows? But yeah, it's quite a beautiful machine.
Just on the topic, I'm looking at your compare speeds chart. It's probably more useful than memory clock and base clock and all that stuff is if you were to look through and like put down the like number of fader units and RT cores and that type of stuff, because like if you compare a 4090 to a 3090, 4090 has like 16,000 like shading units versus like 10,000 on a 3090.
Slow down. What are these called? Shading units?
Like the shading units and like the tensor cores and the with the RT cores. I don't know if that's ray tracing cores, but I don't know like which ones are being used by these models. But
well, this is exactly what I'm doing. I'm trying to figure it out. So what?
So you got like shading units, and you got like TMUs, you got ROPs, you got tensor cores. Like I think that's gonna. Those are the types of things I think are going to make a bigger difference. And again, generationally, they should be better. If you have the same amount on the newer cards. But,
oh, there we go. Shading units. Interesting. 496. Okay. And then TMUs. What's that?
I would have to look that up.
Tensor cores. I'm just looking at the 3090 on Tech Power Up. So tensor cores 328. What else should I compare? Shading units, tensor cores. There's TMUs, ROPs, SM count. What are all these?
I am not completely sure. I just know that
Okay.
shading units, tensor cores are the ones that I'm more familiar with, just knowing those. But a quick search should tell us.
So let's see. Okay, so I got the shading units and the tensor cores of the 3090. Let's do the 4090 now. And see if we can find the exact, because like, yeah, I haven't been able to find like the correlation between speed.
TMU is a texture mapping unit. So yeah, I don't know exactly which things are used by the different models, but
16384 tensor cores 512. Okay, interesting. Well, see, these are interesting numbers. Okay, I'm gonna start filling these in and see if I can find another correlation between, like, yeah. Anyway, I did do the memory clock, like the H100 has the exact same memory speed as the A100, but it does it twice as fast, right? So like that's weird. And then, so like memory clock speed, like memory speed doesn't seem to affect. Like the 4080 has a much higher clock speed than the 4090, but it does it like 6 times as slow. So it's like, okay, so memory clock speed is like not affecting anything. Base clock speed isn't affecting anything. So yeah, I'll have to jump into these shader units and tensor cores and start doing some.
The other thing too, I guess, when you're talking about memory on things, are they using the same? I just don't know. Are they using the same type of memory? I mean, is one using like, you know, DDR6 and one using DDR? I mean, I guess DDR7 is not until next gen, but you know, that type of stuff too. So you'd actually probably want to compare the GPU bandwidth, overall bandwidth, rather than the clock speed.
Bandwidth,
So
okay,
like, what
yeah.
am I looking here? On the,
Baba Bear, we're gonna have to get you. So a GPU band width.
Yeah, so
okay.
like I see here, like the this is the 4090 is using. Let's see, the bandwidth on that is 21 gigabits per second, and on the 3090 it is. They put them in different places on the same website. 19.5. So there's a not a huge difference, but a little bit of a difference between a 3090 and a 4090.
What about a yeah.
No, yeah, I wanted to say, so for my reinforcement learning research, it's different. But for this big matrix calculation, what will have the most benefit is having more CUDA cores. So you can look at that as well. Maybe that here, because it also are IE models, it will also help. I think it will. So for example, the 490 has around 60,000, I think, and the 390 has around only 10,000.
So the shading unit is the CUDA core. Then it sounds like that's the.
Maybe I don't know what I know what shaders
well,
are in games.
the two numbers that you gave are what's listed as shading units on tech.
Okay, yeah, then it does shading
so
units.
sounds like those are same. That's what the CUDA cores would be then.
Oh, I do want to mention that. Okay, Authority, you linked this Threadripper. I believe this. I've been hanging around in the io.net Discord, and I believe the Threadripper actually does the inference. So this replaces the GPU. So this is not supporting the GPU.
I hope it does.
Yeah.
For that price.
Yeah, I mean, it's the price of an entire build, so...
Yeah, so
what cook me breakfast
what you should do is buy it, and then benchmark it for us, and tell us if it's a good buy.
Sure. Do I get retroactive funding for that?
I don't know. You're gonna have to ask the community on that one.
Has to go for vote.
It's so expensive. It's ridiculous. Yeah.
Benchmark it and then return it. Joke.
I mean, you could.
I don't think you can.
But the io.net
the code isn't written to take advantage of CPU for that. I'm pretty sure. So I don't think you could benchmark it.
The io.net guys released support for the Threadripper with the 4080. So I don't know if that's because they do similar benchmarks, but yeah, I'm thinking that maybe it's not up there with the 4090s or aboves. But I just don't see how, like, because you also need the RAM to handle that and the motherboard to handle the CPU, whereas the GPU, that all comes together in one package, right? So again, like my theory is buy 4090s or buy 3090s and stick them on these $100 all-in-one motherboards, and let the machine melt, you know.
Yeah, I think I do something similar. I just use €300 motherboards and put multiple GPUs on there, but it's probably the same.
Yeah.
So I saw a question in the chat, I think, from Arunas. Let me go back to it. So he says, can anyone participate in the subnet testing? So we still have to coordinate that, but basically what we will do is we will first see how many people want to participate. I think the more the better. You can fill in like a Google form. I think Rich will share it with the community this week. So we will see what people have, what hardware they have available, and then we will onboard everybody that wants to participate there. So
just a quick question about that, Rick. Then, so is it going to be like important what GPU you got? I mean, what model of the GPU will you get the? Will you get picked if you got 490 over 3090, for example?
yes, so I think we did not yet decide on that. So we have to discuss that. So what I see myself is that the 390 it's good enough. The 490 is good enough. I think Titan knows more about this. And in the end, if you can do the inference faster, yeah, of course, then you will be chosen faster because your latency is lower. So it will help.
Arunas? Oh no. Yeah, who's asking this?
Jonas.
Jonas? Oh, we just asked that you go out and buy an H100 for us. It's only $30,000, and then you can join.
Yeah, no problem with that.
You will
get money.
I went out and bought a 3090 just for the subnet testing. So I went and found one on Facebook Marketplace for $800. Yeah, so that's what I did.
I bought this as well, like 750 or euros or something here. But I think for the subnet, you will get an update this week at the end of this week, at the latest next week for the rest participants. So we will first make sure that the subnet works with a small group of 4 orchestrators, and then we will onboard everybody else.
Cool, thank you.
With that being said, I'd like to segue into inference speed and inference time, if that's cool with everyone.
Yeah.
Okay, so after doing some more research, people graciously putting their GPUs under fire with my testing binary and getting back a good amount of initial data. The first thing I found was, so I have a couple concerns. In a forum post, I was so initially I was trying. My goal was to get low RAM GPUs to be able to do all the jobs. Okay, I thought that this might be important. Is I have a 8 gig 4070. I want it to be able to do all the jobs on the network. Right now, it can only do basically the text to image and some of the image to image, but it definitely can't do the image to video. And video is what Livepeer is all about. So it would be kind of weird if we, orchestrators in general couldn't do the video generation part, right? So I thought, okay. So my first task was to try and get low RAM GPUs to be able to do the jobs. Okay. And I successfully did. I was able to find 2 flags that if you enable them, they drastically reduce the RAM use. In turn, increase the inference time, the time it takes to do the work by quite a bit. So, what required usually 18 gigs of RAM, I got it down to 8 with a sequential offloading, got you down to 8. And then if you included forward chunking, it got you down to 4 gigs of RAM. So this meant that like almost every card that has 8 gigs of RAM, which is a lot of them, can now do image to video job types. Okay. In doing so, though, it increases the time to do inference by about 10x. So, for instance, my 4070 8 gig card, it took just under 10 minutes to do the image to video. So if you can imagine, 10 minutes is a very long time. And I believe the inference job is the output is what's in the demo app we used, which I believe are those 3-second videos. I think they're 3-second.
Maybe like a second and a half, but I could be wrong.
Yeah, okay, well, if they're a second and a half, then it takes 10 minutes on my 4070 to do a second and a half video, right? Chunk forwarding, yes, I said that, Rick. Chunk forwarding and sequential offloading combined gets you down to 4 gigs of RAM. But a second and a half video takes 10 minutes with those two enabled. And for Papa Bear, he actually just posted his 4090 results, and his took 356 seconds. I believe that's 6 minutes. No.
You're talking about with the chunking thing? Yeah.
Yeah.
Right. But what was it, 35 seconds without it? Like, is that what it
So, okay. So, as you can see, okay. So then I went to Quan, and I said, Quan, for your app you're building, are you okay with a 10-minute inference time? And he said, what? Like, no. And I said, okay. What are you looking to get? And he says, ideally under 30 seconds. And I said, ruh-roh. Because the only GPU that can do under 30 seconds is the H100. Single-handedly, the only GPU. Okay. So let's back it up here. So Quan, for a UX user experience on the front end, is aiming for under 30 seconds. The 4090 by default, the default settings, can do 50 seconds. So that's still almost twice as slow as what Quan is wanting. So it's just about a minute. And then the 3090 does it in 93 seconds. So that's a minute and a half. So out of the gate, I think we're going to have, with 3090s and 4090s, we're going to be sitting at about a minute to a minute and a half rendering time for image to video. Okay. And that's with cards with 24 gigs of RAM. Now, so that's interesting. So then I went, okay, I don't think we should be optimizing for low RAM GPUs because that's not the way Quan wants to go, at least for his use case. And I figured out we can do low RAM GPUs. It just takes like a long time. Okay, so we know we can go lower RAM and longer inference time. Maybe we need to go the other way. Maybe we need to hit 30 seconds for higher RAM GPUs. So I've been trying to work on faster inference time, but I've failed at that so far. So
yeah, I have not looked at faster inference time, but I see the Pepper Bear has like the image to video, the first one, like model 1. He has 31 seconds.
Oh, sorry. Oh, that is using the SFast.
490.
Yeah, that is using
the SFast. So you need SFast. So SFast will be good enough here for the 490. The 390 will be twice as slow, I think. There. So I think you can use it lower GPUs in the future if there are different jobs. For example, if people want to have this rendered videos and they want to wait 10 minutes because it's a different platform. But for his platform, of course, users want to have their meme fast. So it's not like an off loading test that you can let the cloud do.
Yeah. So I think there'll be a lot of UX, UI designs built, I talked to Doug about, or like I talked in the forum about this, about like if time isn't a factor, then we could drastically lower the price because we could unlock so many more GPUs that can do it without a quick time frame, right? But oh yeah, so the SFast, sorry, if the SFast flag is involved, okay, I'll take that back. The SFast flag does reduce the 4090 down to 30 seconds. So it's right at the limit, or Quan, and then the 3090 is at 67 seconds, so twice as slow. So it's at a minute.
So for his use case, the 490 would be perfect. And I think also at his app side, there could be some improvements because he now generates the video at the end stage, but he can also generate it already when he has the image in and when people are writing the caption. So then when they're writing the caption, you also win like 10 seconds or something.
Yeah. The other thing I noticed is Strunk had a 16 gigabyte 4080 that was equivalent in speed as the 3090. So I think, but yet the 4060 was a lot slower. So it looks like the 4080 Ti, no, not the Ti, the 4080 16 gigabyte version is also up for, it's equivalent of the 3090, right? But as
Yeah,
for,
I saw that.
as for Quan's requirements, it looks like he's looking for basically the 4090 with SFast enabled as kind of the minimum.
So I think that makes sense because the 4060 has only 3000 CUDA cores and the 4080 already has 10,000. So, and the 4090 has 16,000. So it gets close there. And I can look up what 3090 has. So that will be probably the same then. So the 3090 will have 10,000 CUDA cores. So it's the same as in my research as well, I think, with that you.
Oh, so CUDA cores that matter.
Yeah, that's what I see in my reinforcement learning research there.
Where,
if you have big networks.
Where's the CUDA cores on the tech power up? Transistors, CUDA cores. There it is. 16,000. Oh, okay, cool, awesome.
So the interesting thing is that an 800 only has 18,000 CUDA cores. And it's a lot faster. So it's not the only factor there.
Yeah. Again, I'm gonna do some more research into what kind of makes the GPU fast enough. Yeah. So anyway, now there are flags where you can use more RAM and speed up inference. So
I have not looked into that.
So what we can do is, because the model it reserves 18 gigs of RAM but only allocates 12. What we can do is there's more RAM available in that model for the image to video. So I'm wondering how much faster we can speed it up. Now, I have been playing around with it a little bit, but I'm unable to get, I don't know where to place the code in order for to utilize this optimization. So I might need some help with that.
Yeah, no problem. I can help with that. But which flags are you talking about?
Hugging.
Is it the memory efficient attention? I don't know.
Optimization, speed up inference. It's tensor float 32. I put it in the chat.
Oh yeah. And you can make it even faster if you go to float point 16. And you can see like the latency speed up table. But it will influence maybe your results a little bit because it will use less floating points. If you see it here, that will speed it up as well. So there's also memory efficient attention. I have not used it. That's the fastest one. And the trace unit is also faster. And I don't know the TensorFlow 32 where it falls in those.
Wait, where is FP16? Where are these? Memory usage guides.
So we already use, I think, FP16 in the code. I can check it if it's available. So if you download the FP16, it will use that one.
Okay, so we're using FP16 already.
Yeah, if you download that one. And I think if you're using the download checkpoint file from Yonden, then you will be using that. So there are some optimizations that are faster. You can see the memory efficient attention, but I don't know if it's available with the models we use and the trace unit. So I know that the trace unit is more available than the other one. So you can try to test those out and see if they're available.
Yeah. So yeah, I'll have to. Again, I don't know where to. Maybe that's why the float 32 wasn't working, because it's already using the FP16.
Yeah, I think that is it, because it's in the code.
Yeah. Okay.
So
yeah,
if you don't download the 16 safe tensor models, then it will work probably.
Right. But it'll probably be looks like the FP16 is going to be faster likely than the Float 32.
Yeah, it uses less precision. So that's basically what it is about. So it's
Oh,
the
is
same
it?
as if I think. Yeah, I think it is the same as if you go to MPI, float 64 and then float 32, and you can even higher go doubles in some languages.
Right.
So if you have more floating points, you need more space to store those and do those calculations. That's how I understand it.
Because the other one, yeah, it's half weight precisions, but apparently that affects your actual output.
Yeah, that's correct, because that's the float 16, because it's using less precision. So
Oh,
some
that's
of
the one
your
using less precision. Oh, okay.
yeah.
Okay. So
what
we're
what
already
basically happens is
using half weight precision.
yeah. So the only ones that I know of, that's the one that's in the table that you can try to use, is the channel last, traced unit, and the memory fist attention. But I don't know if they're available for the models we're currently using.
Okay. I suspect
So that will
Yonden's
be
probably already put
3.61.
in. I suspect he's already put in the speed up optimizations. Maybe not, but based on what I see, yeah, I went with the memory reduction optimizations, and like I said, I got them to work, but that's might not be what we're going for.
I think that will be important in the future. If you have, for example, tasks that you can do in batch and you want to render a lot of videos and you can wait for 1 hour, there will be use case for that. But with the current D app, that's not the use case we have.
Yeah, because what I want to have a use case for is I want to convert all these water cooler chats into summaries with cool videos. So you don't have to rewatch 2 hours of these water cooler chats, but maybe you could watch you can use the sentiment AI to like get the transcribe the video, get the important parts out of it, replay it using the AI, the man robot voice guy, and then do a video that's more interesting to watch rather than just this like Discord, just like nothing to look at, right? That would end up in like say a 10-minute video or a 5-minute video. So if you can imagine, a 5-minute AI video is going to it's a lot, right? But if we can but hey, I don't mind waiting like a few days for the video to be generated, right? So I could distribute that 5 minutes across 10 low RAM GPUs, and in 2 days come back and it'll be done, and it's good enough for me, right?
I think that's a perfect use case there. So basically, I think that will be another capability then. And
Hey, can I chime in real quick? That's what my team and I are working on now with our app. And we've been using some of the discussions that you guys are having, and we're building it into the gamification aspect of our app, with the understanding of the potential client and customer not understanding the verbiage or even the ecosystem or the environment, and making it more palatable and engaging in a way that can be tracked via whatever metrics that we assign to it.
Yeah, well, there you go. Yeah, this is all very new and very interesting, so it'll be fun as we go forward. So anyway, I will stop beating this topic to death, because we're going to spend a lot of time here, I think, as a community.
I think there's one question from Marco. That's the last one then, maybe.
What's Marco say? What kind of... Yeah, go ahead.
Yeah, you can read it. You have a radio for it.
Oh, thank you. What kind of video does the image to video benchmark generate? Could be more taxing in frames per second, duration, resolution. What Quan is looking for in his app? So that's a good question. Right now, we are, if you go to the showcase tab in Discord, this is exactly what we're benching So these 3-second, 520 by 520, 14 frames per second videos. I believe that's what we're making right now. So from my understanding, if you want to increase the resolution, yeah, well, everything affects the amount of RAM you need, and so if you increase the frames per second, the duration, the resolution, the accuracy of what you're trying to get, these all affect RAM and inference time. For instance, with a 3090, I increased the frames per second to 30 frames per second. I thought, hey, 30 frames per second. And it increased the RAM by like over double. So I think it got up to 30 gigs of RAM required for 30 frames per second. And then I increased the what's it called? The dechunk size. I think that's the accuracy of the model. And that again doubled it. So on an H100, I think I also increased the resolution to 1080p. I did 198 by 1080, I think. And again, that significantly changed the requirement to the point where only the H100 could probably handle those, unless you do forward chunking and sequential offloading, which are the RAM preserving jobs, which would then slow it down. So it's just a trade-off. Like the higher quality stuff requires more resources. And so, yeah, it just comes down to like, as a network, what quality of stuff do we want to offer, right? Yeah.
Yeah, I think that's a great answer. So it will affect it in the end. That's what I also saw. So if you need battery, you need more memory and you have slower times.
But just to give an example, though, I don't know this. This is just based on like what I've kind of seen. But I don't know this, but this is a guess. What you've seen with Sora, like those like that like 30-second long, pretty high quality, very accurate, all one length video. I'm going to assume that is a box of 8 100s parallelized to act as one GPU with the highest settings with all the memory savings used possible. Like that's so just to give you an example, I think that's what that is. Whereas, yeah, we're doing 3-second. The app that is being built are 3-second, kind of low quality, not very accurate to the inference. But hey, they can do it. You could do it on a 3090 in 30 seconds, right? Or 4090 in 30 seconds. So I think it really just comes down to the front end app or the use case, and you have to like figure out what it is we want to optimize for.
I mean, Sora is a completely different model. I mean, it's not using any of the current models that are out there, so I think you have to factor that in as well.
Yeah, well, again, yeah, like I don't actually know because I don't, but just based on me flicking around with the numbers and Stable Diffusion, yeah, the more intense, the higher the quality, the higher the GPU requirements.
Yeah, I think OpenSora is also doing like GPU parallelization. So TensorRun does that. So that's also a way to do it. So you can do it in 490s. That's the OpenSora. It's not the closed model from OpenAI, but it's a reproduction. It can run on multiple GPUs.
Yeah.
So I think that was the last IE question in the chat.
Yeah, okay. We've been at this for like an hour and 20, so
Yeah, so I have to go. Unfortunately, I have to do some work. So, but if there are any questions, let me know, and we will update you in the community chats. I think this week or the next week about like the bigger subnet test.
very good. Yeah, very exciting. And thanks, Rick, for all your hard work.
No problem. Exciting times, exciting product. So
Yeah. Cool. Great. Let's move on to a couple more topics. Mike, you had a topic around the Dancun upgrade. Do you want to tell us about the upgrade and what impacts it's having on Livepeer?
No, I think we all saw it. There was some conversation in the Livepeer Discord about gas prices going down as a result of the Dancun update on Ethereum. And, you know, gas prices go down, ticket payouts are a function of the gas price. So as a result, you'll see that the payouts happen in the ticket channel, the payout channel, a lot more frequently, but the value has gone down quite a bit. So again, I'm just stating that because that's what we've all seen. I don't know if there's a problem or anything. I just didn't know if anyone had any more context they wanted to add, anything more to talk about on that topic, but I noticed it. And, you know, just looking at Livepeer Tools, the website I built that shows ticket payouts and stuff, it looks like, you know, prior to the Dancun update, you know, there would be about maybe 20 orchestrators that would get tickets in a given day. And I look now, you'll see every day since the update, there's about 50 orchestrators that are getting tickets daily now. So it expanded the number of orchestrators that are actually getting paid out, but the values are lower. From a total amount paid out, it looks the same. It looks pretty consistent that the same amount of ETH is being paid out per day, but it looks like, you know, just being distributed amongst more orchestrators. That's my kind of anecdotal addition to the conversation. I don't know if there's anything anyone was curious about, if they were wondering what happened, but at least maybe that gives some light onto it.
Oh, interesting. Yeah, I've noticed that, like, I'm winning tickets, but it's not... Oh, right. Varies' bot is not telling me when I win tickets now. Is that...
Yeah, I didn't even think about that. That's probably the case. Yeah, you're getting tickets, but they're not showing up in the Telegram bot. I didn't even think about that.
Which makes sense because I don't want to get spammed. Varies, do you want to talk about the Telegram bot?
Yeah, I mean, the bot actually records every ticket and then it notifies once you have hit a certain threshold that is defined by your stake. So yeah, to avoid the spam.
Oh, that's right. Okay. This is why I was... Because it was telling me, like, oh, you know, I got 0.24 ETH in a ticket, and I thought it said ticket. I don't know. And then I went, well, I don't get tickets that size, so I don't understand. That must be wrong. But it waits until I hit that threshold before it notifies me. What I'm assuming.
Yes, exactly.
Okay.
But if you look at the payout channel, you're going to see a whole lot of tickets going on.
Yeah, this payout channel has reached next level spam. That's okay. You know what? Out of all the channels, this is the one I don't care about spam. You know, this is the one.
Hey, more money coming in.
Yeah, Bitbender. Who's Bitbender? Oh wait, what are what are these? Are these different? Are these their logos or yeah? Oh, interesting.
Yeah, Bitbender has a new logo, NYC Philanthropy. You get to see them all now because they're showing up very frequently.
Yeah, that's too funny.
But again, I think though, if you look from a total ETH paid out by the broadcaster, it doesn't look like it's more ETH. So, but it does look like it has impacted orcs. You know, it means that if 50 orcs are now getting tickets with the same ETH amount, that just means that collectively we're all getting less, but it's being spread around a lot more.
And it also gives you confidence that the probabilistic micropayments has been working properly this whole time.
Well, I see a lot of back-to-back tickets. You know, I still don't understand how individuals can hit 2 and 3 tickets at once with a probabilistic payment system in place. It just seems odd that so many of these duplicate, triplicate hits are happening now. It actually, when they switched from the selection algorithm, it seemed to, or they fixed the first segment change that they did back in, I forget, November or whatever. That seemed to eliminate back-to-back tickets. We weren't seeing any more of those. But now, lots of back-to-back tickets. So again, it could just be coincidence. I don't know if it's related to micropayments, but I just see so much more of the batches of users hitting or orchestrators hitting tickets concurrently.
Well, there you go.
Again, maybe it's not as critical for folks anymore to think about tickets like that anymore, but I still find it fascinating to look at patterns of behavior, you know, of how this stuff has been paying out and working. And it's been really different over the last 7 days. So
yeah, I like it.
I mean, what is it? It's like 2 cents down to claim a ticket, whereas I think it was like, you know, averaging around
30 cents.
30
yeah,
cents.
20, 30 cents per reward call, and also ticket redemption. So that is also another impact. Good call out, Papa Bear, that the gas fees for the transactions themselves have significantly reduced. So that's a good thing. We can let our dummy wallets run a little longer.
Well, yeah, reward call is it's 2 cents.
Yeah, but it used to be 30
Oh
cents.
no, I thought you were
varied.
Yeah, 30. Yeah, it used to be 30. Yeah, we're creeping up on Solana levels here. We got a few more decimals to go, and you know, creeping
That's
up.
Great.
Creeping up on.
That's great.
Soon we'll be launching meme coins on the Arbitrum network.
Please no. What that means for Arbitrum node operators would mean a lot more busy servers.
Yeah, definitely.
What was that, Ben?
Or was that
I
Alvin?
think that was Alvin.
Oh, was that Alvin?
There's so much meme coins ongoing on Solana, and everyone is like, yeah.
Yeah, everyone is going crazy over in that network.
Yeah, we can leave the meme coins on other chains. Please let Arbitrum be the safe space.
Let's go.
We don't need them here. Come on.
Let's go over and do an Alvin Rocks meme coin on Solana, so we can just promote our #1 community leader.
Yeah.
I'll buy it. I'll pump it up and airdrop all the profits to Alvin. How about that? Perfect. Cool. All right. Yeah. The Dancun upgrade is pretty cool. It was interesting. I woke up just to watch it, just to see the ETH validator like do it. So it was pretty anticlimactic. Probably should have just stayed in bed.
Yeah, well, unfortunately for me, since I run that ARB node and folks are using it, it was a bit nerve-wracking just making sure that everything was lined up in advance so that it wouldn't cause outages to anybody. So thankfully, it was kind of anticlimactic, but at the same time, it was a bit nerve-wracking in preparation, making sure nothing goes wrong, no outages for anybody. So it was good.
Great. Okay, let's keep going on with some more topics. Rumbling Thunder, you had a question about Livepeer Studio and transcoding minutes. Do you wanna tell us your question?
Yes. So on the dashboard, on my end, it shows like some usage metrics. Mine are at 0. I have like 8 videos that I've uploaded onto my my channel. So I'm trying to figure out, what those numbers mean, because I know there's tiers. So for the tier that I'm on, I think allotted 1,000 transcoding minutes. So I'm trying to figure out what is difference between the level I'm at now versus the next tier, and how to make those numbers move. Really, what does that look like?
Unfortunately, is anyone here involved with Livepeer Studio? Probably not. We'd probably have to invite someone from Livepeer Studio to answer that. I don't. Unfortunately, that's like a not unfortunately. Fortunately, they're a great team of people, but they are they basically run their own platform for doing like a fully hosted front end. And so we don't know. I don't think anyone here knows the answer to that. Maybe like Marco knows a little bit about Studio, but don't know. So what you're saying is you're uploading video assets to Livepeer Studio, and your transcoding time is not increasing on your metrics board?
Yeah, 0.
Hmm.
And the videos I have, they have analytics on them, so seeing that they're getting views. I'm just trying to figure out the analytical aspect of it, so that I can understand what I'm looking at.
What about have you done any live streaming, or is it just video uploading?
Just video uploading. So is that what it is? Is it live streaming only?
Well, video uploading should be transcoded. I mean, that's a part of the process, but maybe it doesn't affect the dashboard minutes. I don't know. But what I would recommend trying is like just throw some live stream minutes through it and just see if that makes it increase. Like if you're familiar with OBS, like just go to the stream section, get the RTMP key, and you just throw that into your OBS and just start streaming through it for like maybe half an hour and see if that starts making it tick up.
Okay.
And then that way, yeah, you can see.
I've done that. Yeah, I've done that where the live streams, definitely I've seen minutes going up, but I've never used the upload feature, so I couldn't tell you.
Well, I started a stream into my account, which I haven't used in a long time, and I do not see the transcoding minutes going up it's been, I don't know, 2 minutes or so, and
Oh wow,
0 transcoding
maybe it's
minutes.
broken.
So there may be a problem, so you might want to send in a I don't know what they have here too. Well, maybe post it in the Discord.
Developer support. Yeah.
Yeah.
Developer lounge is probably good. That might be a broken value right now. You found a defect.
I'm here to stress test.
Yeah, no, because I definitely used to see, like I used to test it. I would see it go, and it's definitely not moving now. So.
But no, all seriousness though, I did, obviously come, or was introduced to Livepeer because of the live stream aspect. But because I have so many different types of video assets, I wanted to see, how I could utilize those things, but without any data. That's what I'm asking the question. does that affect it, or if you guys are saying there's a problem, it should affect it. So,
Yeah. I don't know. To keep testing around, or maybe even just reach out to the Livepeer team and just ask them what this means, and yeah, see what happens.
I appreciate you guys' insight.
Cool. Yeah, because that when you go to the Livepeer Innovators DAO, that might be an interesting metric to share, to show the amount of demand being generated to the network. So it could, if you do this application or future applications, like, it's good to keep track of those kind of numbers.
Are you familiar with the Ninja metrics?
No.
Ninja metrics is what I've named the metric that we're using in our app to do exactly what you're saying. Because like on the other side of everything that you guys have been discussing in regards to video, when we talk about transcoding, and obviously the size and quality and all of that is going to affect the inference. It's the same exact workload and obstacles to create it and present it to be seen, whether it be on YouTube or Instagram or whatever. The larger it is, the heavier it is. And because of these things, those social media algorithms are programmed to prioritize those things that have a certain volume or weight to them, per se. And the Ninja metrics is really just about associating the metrics that are used on a commercial side of a dashboard on like social media and integrating it into Web3 practicality. Because it's not really something that we had this conversation last week. You guys told me that once you guys transcode a video, like, you don't care about how many views it gets afterwards. So that's that space is where our app lies, and that Ninja metrics are those numbers.
Mm-hmm. Definitely. Very cool. I like it. I like it a lot.
This isn't the issue with the minutes that you were seeing it from uploading, but I do see here there's a hover over that says usage minutes may take up to an hour to be reflected. I'm assuming that's for a live stream, so that could explain why I'm not seeing anything go up with the stream going through, but just throw that in there for observation.
There we go. Cool. All right. Well, we've talked about a lot about AI stuff. We spent a lot of time on that. Dancun upgrade, Livepeer Studio, setting up an AI runner for the upcoming subnet testing. The last topic I wanted to cover, which was the CUDA 12 and Linux. I tried to get CUDA 11.7 to work, and I couldn't, and because I had, I think, maybe GPUs of different generations. Like, I had a 1660 and a 4060, and CUDA just didn't like that at all. The driver had, like, I don't know. I could not figure that out. I think it didn't understand that the newest driver could handle the older card, but the CUDA 11 didn't work with the latest driver, and so I don't know. I gave up. Just
worked for me. You're talking about the CUDA version, right? The changes with
the
some of the newer versions of Livepeer.
The toolkit needed for transcoding on Linux currently.
Yeah, I had to do that recently. I updated Livepeer and was met with a surprise of you are not running the correct CUDA version errors. So I went to the links that I saw in the orchestrator chat, downloaded the correct toolkit, and it seemed to work okay. After that, I didn't run into any issues. I believe I have at least one server on 12.1 at the moment.
Yeah, but you're running a single GPU. He's talking about an older GPU and a newer GPU in the same box, right? That's what you're saying, Titan?
Yeah.
Yeah, I think there's definitely each GPU has a minimum a minimum driver version that's needed to run the CUDA toolkit. And there's a matrix that you can find on NVIDIA. I could have to go look for it, but it basically says for the CUDA version you're running, there's a minimum driver version, and some of the older cards may not support those driver versions. Like, and again, I can't recall off the top of my head what some of the older ones are. I think like the older cards use like the 525 driver and the 515 driver. And I think those lines aren't supported on CUDA 12.
And
like
Ben,
you have
are
to
you
be
running?
like 535 or I think it's actually even higher today. Go ahead, Papa.
Ben, you're running Docker, right?
Yeah, I'm running Docker. And I'm on the absolute latest driver that works with Livepeer and patching.
Because Docker, as long as you have the toolkit installed, has, I mean, that's all baked into Docker, right, Mike? I mean, isn't that's the reason that Docker's been so pushed for this latest.
Yeah,
release.
the CUDA libraries needed for Livepeer are inside the Docker container.
Oh,
But
maybe I should run Docker.
that might actually help you, Titan.
Join
I
us,
don't
Titan.
know.
I don't know. Actually, running Docker with this AI subnet, I finally get the power of Docker. Like I'm like, oh, I get it. Like you don't have to install dependencies; it comes in this container.
Yes,
because I tried to install everything that was in the container, the subnet container, and like I couldn't. Like I was running into so many issues, and I was like, okay, Docker is way easier because I could download it on this machine and that machine, and it all works, right? So I was like, oh, okay, I understand the power of Docker now. I give in.
Yeah,
I've been converted.
If we
it
all
doesn't make
switch
it
to-
easier though. It's still not. You know, there's a layer of abstraction on top of the operating system, which can make it a bit confusing. So don't beat yourself up for not switching.
Yeah.
Go ahead, Ben.
Are you good? I was just going to ask if we're all switching to, hypothetically to like Ada 4000s, this whole new sense of drivers and installing the latest ones and patching, that's sort of a much smaller issue, right? Because we don't need a patch anymore for those cards, I think.
That is correct. That's correct.
Okay, well, I'm looking forward to that.
Which ones?
The
The
RTX 4000 Adas. Or, yeah.
Oh yeah,
I know there's two
those
different
are the
4000s. So
commercial grade ones, right?
right.
Yes.
They come unlocked. So.
Yeah, the professional ones come unlocked by default.
Awesome. That just makes things so much easier from a node maintenance perspective. Like anytime you want to update anything, you have to reinstall drivers and patch, and that would be nice to get, put that away.
Yeah.
Yeah, but if it was easy, then like, what are you doing with your time, Ben?
True. Why do you think I'm trying to build the most ridiculous build? For AI, I got to make it hard for myself.
You still playing World of Warcraft these days? Is that what you're using your time on?
No, no time for that, unfortunately.
Dude, one of the best times I've ever had in that game is I played with Ben, and like he's like never done arenas, like per player versus player, and I was like, dude, like that's all I do. It's all I just come play with me, and we were just rolling through people. We were winning every match. It was amazing. It was just like
that was awesome.
Cool.
That was good times,
dude.
Yeah.
We were just killing it, and he was like surprised, and I'm like, well, I'm not bad, like I'm pretty good at this, but I was impressed with Ben's ability to pick it up. He was just like pewing people down. It was great.
Yeah, I had to force quit that game because I was starting to get really, really addicted, like raid groups, and it started to feel like a full-time job. So I got the hell out of there.
Yeah, a week after
An
we
unpaid
played.
job.
Yeah, a week after we played, I quit, and I was like, okay, that's enough.
I think we've all gone through that video game phase. I remember this was a long time ago for me, and I played World of Warcraft eons ago, but it's probably been at least 10 years since I've touched that.
It honestly feels so weird like about to build all these crazy rigs, these insane high performance rigs for Livepeer and whatever other nodes are out there. And like I'm not building anything for myself. Like it used to just be I'll build a computer for gaming or whatever, right? Now it's all right, I'm just building this so I can do cool AI stuff and transcoding. It's like, damn, not a kid anymore. It sucks.
Well, you got to become a developer, because then developers have, like they just said, hey, you can get that Threadripper for compile times. If you're a developer, you still want to build a rig that can compile your code faster and run it a little quicker. So you gotta join the next level of video gaming, which is called development.
Yeah, fair enough.
Yeah, I still want to try and figure out like how to get these water coolers transcribed and then make like a 5-minute video of AI. Just like, who knows what it'll look like? Like, who cares? Just let it go. Something a little more entertaining than just watching this Discord chat. And yeah, see what it does. But
sounds like you're taking on a developer game on.
I it's a cool concept, but then as I'm digging through like the Hugging Face code and like I can't get it to work on my local machine, I'm like, okay, whoa. Rabbit hole. Like, be careful. I don't know if I've got this much time on my hands.
There's dragons down them holes.
Yeah. So anyway, cool. All right. Well, we covered all the topics. With that being said, do we have any more comments or things to say before we sign off? All right, cool. I do appreciate everyone being here, and what I'm going to do is go back and start seeing if CUDA cores is what makes the difference with the inference speed or GPU bandwidth or shading units or tensor cores, according to Papa Bear. This has all been very educational. So thank you for all the support. I do know that these water coolers do help us advance as a community and learn off each other. So thank you all for coming from all 4 corners of the earth, or 5 corners.
Thank you, everyone.
Thank you, Alvin, for staying up so late and being here. It's great to have you. And with that being said, I'll sign us off. We'll see you next week. And thanks for being here, making Livepeer the most decentralized and open video infrastructure around the world. Cheers.
Thanks, guys.
Bye, everyone.
Right now.